It's Don here from the board. Thanks for coming along and checking out this video. So, it's been a very long time coming, and as per the video title probably tells you, today I'm going to be unboxing and having my first in-person look of the Downbubble prototype case. Now, before I get to that though, I want to give a shout out to our new Patreon. Peter, thank you very much for supporting us. Part of your contribution no doubt will go very far into the future and support me as well as the podcast, Kevin, and everything else that we do there, as well as these kind of projects. So I know that people are probably keen and they don't want to hear me rabbit on too much about it, but as I'm switching over, I just want to talk a little bit about what is actually in this box. So if you've never heard of the Downbubble project before, it's basically something that I had designed and developed, which is an ergonomic split keyboard. It is split and angled with a 5-degree angle, and there is a rotated numpad in the middle. Now, there are other videos in the channel previously where I had talked about and shown the PCB for it, and so this is the actual prototype PCB that you can see here. We've got the numpad in the middle, and it's a very gentle 5-degree, and it's driven off the 8090 USB clone of the Teensy, which is there. Now, this version is mounted with header pins, simply so I can actually remove it as part of the testing, but everything else is as per normal components. So I finally put my money where my mouth was, and I went and got a prototype milled in China. What I find really interesting is that this package sent by DHL, the description says that it's stainless steel metal machining samples, and it claims it's 2 kilos. You can see that it says it's meant to be 2 kilos here. I don't know if it's stainless. It probably isn't stainless because I didn't pay for stainless. If they gave it to me in stainless, awesome, but I don't know why they labeled it stainless. Anyway, as for 2 kilos, I do have scales here, so we'll find out once I actually crack this baby open. So it's very, very exciting. I've only seen one picture of this when the manufacturer sent me the picture to confirm it'd been completed and that it was going to get shipped. And being DHL, it came pretty quick. Hopefully it's a massive hunk of metal, so I don't expect that shipping is going to have damaged it. And I can see now that there is foam that they've used here as well, which hopefully should be all right. Yeah, so we can see there's a bit of foam that's happening in here. Now, a lot of people have commented that the edges on this looked really, really sharp because I hadn't paid for any finishing. It was another 10% on top of the manufacturing cost of this to get finishing, and the finishing would have been a bead blast and an anodize. Now, the anodize options was either silver or black. I didn't want to go with black simply because if it scratched off, it'd look really horrible, and I didn't want to go with silver because, well, if it was aluminium, it's going to be silver anyway. Now, aluminium oxidized produces aluminium oxide, which is actually a really great protectant from the environment, but you can get white patchiness. Now, that said, it doesn't really matter because I can still buff it back, and then I can hit it with, like an acrylic coat just to give that a barrier between oxygen and the metal if I really wanted to give it like a seal. So I know I'm delaying here, but it's because I'm excited and I'm nervous at the same time to actually see the fruition of my modeling, and hopefully it will fit. So let's go. Now, this obviously wasn't cheap, especially because it was a one-off cost. The manufacturer I'd asked them what kind of materials they had available and the prices for the different materials. They had offered ABS, aluminium, stainless steel, and then brass as well. The price for the low end was actually almost the same. There was not much difference between ABS and the aluminium, which obviously the majority of that cost would have been the setup cost and programming cost to actually run the actual CNC machine. and there would have been a small gap to the material cost. The stainless was a lot, well, it wasn't a massive amount, but it was expected because it was stainless, and brass was nearly double the cost of the aluminium. So obviously I went with aluminium, was what I'd requested, but if they've done it in stainless, then that would be, there is an inordinate amount of foam here, which is great, but also frustrating me a little bit. Ooh. I can definitely see and feel already sort of the sharpness that people are talking about, and gosh, it's like Christmas. I'm just shredding this packaging. Oh, baby. Will you look at that? Will you look at that? I think it's aluminium, but if it was stainless steel, it's non-magnetic anyway, so there's really not a lot that I can do to figure it out. But I would say that it's probably most likely aluminium. Now, so you can see on the underside, this is what is an example of not having a finish on it. So they haven't actually removed a lot of this nastiness from the milling process. We can see a lot of the actual milling artifacts in these circular swells. It's just as it's being cut. Now, the first thing that I know that people are probably going to say and start criticizing is what is with the corners and the radiuses. So you can see I've got Mickey Mouse pockets happening here, and this is deliberate because I wanted to actually reduce the cost in milling time. So I'd actually made all of my internal corners a 1.5 millimeter radius because that is an acceptable bit size. Now I could have requested it to be a much smaller radius, but it would have increased the amount of time to change the bit as well as cut. Now what's happening here, and you'll see these Batman-y type of wiggles, is that's deliberate. Okay, I know that people are going to look at that and go, what the heck happened there? That is deliberate because that was the plate mount footprint that came on my PCB design, and I had blanket applied the 1.5 millimeter radius. So all of the edges that you would normally see in a plate mount footprint has a 1.5 mil radius, which is why it looks like that. Whereas the simple cutout for a PCB mount looks like that, and it doesn't have those weird squiggles simply because it doesn't have that particular shape. Now, in terms of the actual corners, you can see I've also got the same concept running here. I've got radius at 1.5 in all of my corners, just to make life easier. What is going to also be noticeable here in this case design is it is a 3.5 mil depth plate. So the first thing I need to test, of course, is I'm just going to get any old switcher that I've got here. It's just that sticky Gator-on yellow, and I'm going to shove it through because, well, the pins obviously need to come out the other side, and whoa, that is hella tight. It is incredibly tight. It's very concerningly tight. So the tolerances of manufacture may have been very, very good. Okay, so that's in, and that's all the way in, and you can see that there is a tiny amount of that switch still poking through, which should give me clearance for the PCB and the back of any components that have been soldered. Now, because I used 3 through-hole components on this, I'm hoping that the height that I've clipped it off at is not going to be an issue. We'll find out very, very shortly. So it's good that the switches fit, and you can see they just fall straight out because there's obviously nowhere for it to clip into. And you'll see that the middle here doesn't even, it's actually it's too good, I believe. Maybe the lip should be okay. There we go. So that just sits in there as well, right in the middle. So that's the underside. That's the cutout for the USB socket and reset switch. In theory, we'll find out if that's a good placement. On the top side, some of the features that I've got here, it's a little bit disappointing that on this numpad edge, the actual milling bit has cut into the top of that metal there. It's not focusing very well, but you can see that their milling piece has actually cut into that, whereas that should have been straight edged all the way, I thought. I'll have to go back and check my model to make sure that's the case, because obviously I'll have to write back to them and say, hey look, that's not cool. What I've done up here as well, I've just created 2 pen grooves just for the heck of it, and so that's just that sound, clunk. And you can just rest, you know, pens. For example, my GMK pen. And look at that. Fits beautifully. And it's not going to roll anywhere. How awesome is that? How awesome is that? Now, in terms of the edges, they are hard edges, but random piece of paper. It's not, well, that one's kind of, alright, so that one might cut. What I'll probably do is I'll probably hit it with either some light sandpaper, or maybe I've just got some like paddle pop sticks and I'm just gonna run around the edges and that'll take a lot of that off. Okay, so I know I'm delaying simply because I'm nervous about trying to fit stuff to it. I've got M3 holes cut, but I might need to drill them out because I don't know if I can get a tap that will actually tap the full thickness of the case. And if I can tap the full thickness of the case, because it's going to be like an inch is how thick that is, then the parts that I've got will be fine. Whoa, I just accidentally scratched my Philco with the corner and it took some plastic off the case of my Philco. I'm sorry. Alright, so what I'm going to do is I'm going to put some switches in and I'm going to see if my PCB lines up. Now, I actually don't even have 110 switches of one particular switch type. I've got a sack of some box navies here and you can see on the front I've only got 88 in here. But what I'll do is I'll put them into some key positions just to make sure that the alignment is good, and then I can worry about acquiring some other switches at a later date. So on my PCB, it's going to sit that way, which means I need the pins to be facing up. Actually, before I do that, because I'm starting to get scattered brained, let's find out if it actually weighs 2 kilos or not. So here is my trusty kitchen scales. Let's turn that on. Let's tear it. Oi. There we go. And here goes nothing. So it's only 1.5 kilos for the case. Noting that there is no other components and there's no base on it, I actually don't know if that's really considered terribly heavy or not. So yeah, it's all right. I can live with it. 1.5. It's got an awesome sound to it though. Okay, let's snap in some corner switches. I'm not going to worry too much about these two U ones in those positions because they might shift around when I'm trying to get some of the parts in. But let's just go with the standard corner pieces first, and then we can worry about those ones afterwards. So if everything else is correct, just by putting those ones in, the rest should hopefully line up. Yeah. I'm probably going to be absolutely trashing my desk by banging it here and there. Okay, so here comes the moment of truth. Pins in, pins in, pins are in, pins are in there, pins are in there. Oh, I'm pretty chuffed. So the only thing, so let's just ignore this part because I know that's very high and it's not going to fit. Obviously the proper build will not have the headers on it, and naturally because I can do that, my intent is that I can take that off, I can desolder these headers, and then I can drop that back in and solder it on properly. But what I'm potentially seeing here is the USB port might be an issue. So now the PCB is flexing a little bit, but I'm not sure what's really causing that. It might be something's contacting it. Okay, so oosh, skadoosh, look at that. That is such an incredibly tight fit there. That is not likely to fit a cable. So let me find, so there's a standard kind of mini B, and that is not going to like it. Yeah, so that actually causes it to lift. So this, ladies and gentlemen, is why we prototype. Now, what that means is I need to mill that out. That needs to go further that way. Look, to say that I'm a little bit disappointed would be maybe an understatement, but you know what? This is the nature of prototyping. This is still functional. I just need to get a Dremel or a bastard file and just sand the buggery out of it, and then this will be okay. I also need to figure out what else. See, I think what's happening is these pins here, I might have to trim them flat or something of that nature, because that is also, I think, shorting out. It's going to short out here, which I can see it's already leaving marks. So the Pro Micro, not Pro Micro, but the AT90 will need to be taped over and flattened in some way. So maybe 3.5 mil, because that's what I requested, is actually too thick. I might have to take it back to 2.5 mil or something of that nature. So otherwise, the option of course is to still use it, but with the tape just means you've got to solder some of these corner points in first, and there'll be a little bit of flex on that PCB. So what I will do there is I'm just going to mark it to where I think it needs to go, which will be probably to about there, and I'll just mark that. The other option is obviously that I actually, for the next iteration of this, there's talk about using onboard components, which I haven't really done, and I can learn and move that space. I can move into that space and utilize it. Or in here, I can actually mark it and say, well, for that space where the actual controller is going to be, and basically, you know, do something like this, is to mill that part in. I mean, they're already going to be flattening this out anyway. You can see from all the cuts, So they would just cut that in probably another millimeter, and then it might potentially get rid of that problem. But they're decisions that I will have to obviously make into the future when I get enough funds to pay for another one, because this thing was so frightfully expensive. It might be a couple of months before I get to play again. So, yeah, look, a little bit disappointed, I'm not gonna lie, but I'm also really excited because these are not problems that will prevent me from being able to make this into a usable keyboard at all. I do have a Dremel. It's currently on loan to my brother-in-law because he, well, it was on loan to my sister-in-law first, and she was using it for woodworking purposes, and then my brother-in-law borrowed that so that he could make costumes for cosplay. So all I need to do is just, you know, get the right part, the right spindle, and then I can mill that out myself by hand or file it out, and then I can also mill that patch there for where the controller pins go, and that should take care of that. Overall, I'm pretty happy with how it turned out. Yeah, what else can I say? It's just exciting. It's just very, very exciting to finally have something come out of all of this. This has been a year in the making, coming up very shortly in March since I started this project, and you know what? This is just another stepping stone, innovation, design, because I feel that this could be really, really great. Obviously that edge is quite solid. I might round that off in the next revision somewhat, maybe like a 1 mil sort of chamfer on that. But yeah, really, really exciting. So thank you very much for everybody who's supported this project thus far. I hope that I'll be able to give you more updates as it comes, and what will be the next iteration of the Downbubble. Once again, thank you to all of our supporters, and including everybody on Patreon. Really love and appreciate that, what you guys do for us to help with these projects, and of course keeping our podcast running. So thanks for checking out the video. Don't forget, if you have somehow come across this and you weren't aware that we have a podcast, you can find us at libsyn.com. You can look up us, The Board Podcast, on iTunes, Google Play, Spotify, iHeartRadio, as well as a direct RSS feed. We also post links to our podcast on Reddit and TypeHype as it comes out. Yeah, if you would like an invitation to join us on our Slack group, please send us an email to theboardpodcast@gmail.com. So, as usual, until next time, happy clacking.